Welcome to my channel, and this is the very first video of 8-Bit Basic. I'm going to jump right into it with Family Computing Magazine, volume number 1, number 4 from 1983. I'm going to be typing in the Christmas tree. As I go, I'm going to be explaining the code as best as I can, and then I'm going to debug all my mistakes and run it, and we can have a fantastic 1980s Commodore 64 8-Bit Basic Christmas. Let's go. Line 1, 10 print character string. So this is the character that will clear the screen, and it is 147 on my lovely C64. So when we run the program, first thing that happens is the screen will clear. Poke. So what that's going to do is going to put a specific value in at a memory point. So 53280, 0. So that's going to put a 0 in that area, which is going to set the border color. So 0 is black and 53280 is for border. Okay, 25. We're going to poke another value. 53281, 53281, and it's very close. So this is actually the background color, which is 0. Now, for some reason, the program listing has line 30. It's exactly the same. I've double checked it. 53281, 0. Whether that's to doubly make sure the background color goes to black. If you're a knowledgeable person, please jump into the comments and tell me why this might need to have been done, because I have not been able to figure out why you would do the same poke twice. Line 40 begins our read statements. Now, read statements point down to data tables. So we're going to be reading B, CH, and CO. So B is how many blocks of the Christmas tree is going to be drawn. The CH is the Petsky character, so the symbol that's going to be popped on the screen. And CO is going to be the color. So it'll be clearer in a second. I'm going to show you one of the data lines. Actually, I'll enter in one of the data line now, because that's going to make much more sense as we go. So one of the data lines is 1000. Doesn't hurt entering in now. Data 20, 160, 5, 83, 122, 124, 161, 165, 201. I hope that was correct. 2165, 83, 83, 122, 124, 161. Yep. So what will happen is B is going to be the very first value. So when it reads B, it'll read 20. The next value is going to be 160 for the character, and then the color is going to be 5. So that's how that's going to work, and then it's going to keep going based on what the program wants us to read. So line 50. So this is basically the tree drawing loop starting at line 40. So this dictates where everything about the tree goes on the screen, what type of blocks, what colors, and also the presents under the tree. So if B equals -2, then 140. So that's just going to look for a -2 in our data value, and when it finds that, it means the tree drawing has finished. But if not, just keep going. So that's part of the loop that's going to send it back to keep going back to the data to keep reading B. 64Z equals 1 to B. Z is 1 to B. So in our example, the first B was 20. So it's going to go through this process 20 times. So it's going to draw the block 160, which is the space essentially, 20 times for the color 5, which I believe is green. So that's how that part of the loop works. 70, read X, Y. So this is now going to go to our data table. Let's get back up there. So it's already read B. It's already read the character, and it's already read the color. So now it's going to start reading these spots here, 83, 122, 124, 161. So what will happen with those, and I better go and correct my typo here or it ain't going to work. Read, insert, shift insert, read. Let's come Y, that's better. So the reason there's two positions is that's where the space will start and that's where the space will finish. So it dictates how many spaces it draws along the screen to create the Christmas tree. 84 P equals X plus 1000 to Y plus 1000. So this converts our numbers above to more logical positions. So 122 will get 1000 added to it. So it will become 1122. The next one, 124, will get 1000 added to it. So that is how it comes up with the X and Y values. And you'll see a lovely chart soon that's going to very much clear up what all these numbers mean, because each square of the screen is allotted to one of these values. Let's add in an O. Oh, it's got to be shift insert. I keep doing it wrong. T, O. There we go. 90. So we're now doing some more poking. We're poking P, comma, CH. So what this is going to do is poke the character into the screen RAM. So that's the second number in our data. So 160, which is the space. So that sets the space into our screen RAM, so it knows to draw the space across the screen in the first instance, that is. Poke P plus 54272, comma, CO. So this line here pokes the color into the color RAM for that character. So that's the purpose of that. 110, next P. So that's going to shift along to the next P. Oh, I keep doing this. There we go. Shift along to the next P. 120, next Z. So that's going to move it to the next Z in the loop. And 130, go to 40. So it starts it all again and it'll keep checking. So it's going to go through the big data block, which we're going to type up later, until it sees a -2. 140. So this is our transition to the music data. We have a restore command, which I might even spell correctly. RESTORE. So what that does is resets the data pointer back to the beginning. 150 read X, Y, Z. So that's going to read values from the tree data until our end marker is found. Remember, our end marker was the -2. 160. If Z is not equal to, that's what that means, not equal to -2, then 150. So that just means keep reading all of these data values until it gets to the -2. The code now moves on to the sound setup. So V equals 54296, 54296. No, that's not where equals is. V equals, there we go, 54296. So that's setting the V as the SID volume register. So that way we don't have to keep typing in 54296. We can just refer to it as V. 180. W equals 54276. That's the waveform control of the SID chip, which is the sound chip. 190. A equals 54277. 54277, and that's our attack decay register, which is controlling the sound. So it controls how the sound starts, how the sound finishes. 200 HF 54273, 54273. So that's going to be the high byte of the SID frequency. 210 low F, which is going to be the low byte of the SID frequency, is 54272. .220 is our sustain release register, which is going to control how long the notes sound for. 54278. 4278. Now you're probably seeing me make lots of errors as I go, so my apologies. I will find those when I come back and do my debugging, but at the moment I'm just concentrating on the code and trying to talk at the same time. 230, so lots of setup happening here. pH is the high byte of the pulse width, 542, 54275, and 240 is going to set PL, which is going to be the low byte of the pulse width, 54274. So there's actually quite a lot of controls that go into just playing simple notes on the V chip. The SID chip, V chip, what am I talking about? The V chip, how ridiculous. 250, all right, now we're gonna poke these things. So V, which was set before, which was the volume, we're setting it to 15, which is maximum volume. 260. We're now going to poke W, which was the waveform. We're setting that to 17. We are now poking A to 190, which is the attack decay register. No, 280. 280, we are going to poke pH to 15. So we're setting the high byte pulse width to 15. No, we need to give it a line number. 290, and we're going to poke the low byte of the pulse width PL to 15 as well. So that's all of our sound setup, ready to make our music. Now the program moves into the music and light animation loop. So it does quite a bit of reading, H, L, D, P. You actually have to read it. That would help. Read. No, stop pressing shift lock. There we go, read. H, comma, L, comma, D, comma, P. So on the Commodore 64, to play a note, you need to give a high frequency byte. You also need to give a low frequency byte. So those two things together get combined to create essentially the pitch or the note frequency. The D is going to be the note duration, and then P is going to be the screen position of one of the colored lights that comes up. So I'm going to put in a data line in a second so I can explain that further. I'll just go to the next if H equals -1. So this is one of our markers that tells us to stop, then 140. So when we get the -1, that's the end of the song, and then it tells the program to jump back to line 140. So then we're going to poke HF and H. And 240, we're going to poke LF and L. So that's just going to reset our high note frequency and our low note frequency bytes again. So here is one of the data lines to hopefully make all of this make sense. So here's one of the later data lines, -2, 38, 126, 125, 203, 51, 97, nope, 97, 187, 565, 51. In this line, I'd need to fix this error first because it should not be a full stop, it should be a comma. Shift insert, comma. Okay, now I can talk about the line. So -2 was one of our markers, meaning that's the end. So our first number here, 38, is the first high frequency byte. And then 126 is the first low frequency byte. So 38 and 126 together will tell the Commodore what pitch or what note to play. So that's the HF and the LF. Then the next piece of data that's being read according to our code, 125, is the D for duration. So 125, for those people that know their music theory, it's a crotchet or a whole note. It's essentially a one count note. 203, that's going to give us a position, because that's P, screen position for a light. So there's going to be the chart coming up soon. I promise the chart will be coming, and it's going to explain how 203 turns into a light position. All right, that line is in. 250. No, 240, yeah, 250. What have I done? No, I've gone and rewritten over some of my lines, haven't I? Yes, so glad I saw that. Let's go up and fix. Because here I've done 230 and 240, which will have rewritten the real 230 and the real 240. So let's go and pop those back in. 230, 240, okay. And I'll go back down here and fix those to 330. Where's 320? Did I not do 320? No, that should be 320. Yes, I'm sure all of you sitting at home were horrified to see these mistakes as they were happening live on the screen. So 320, and this should be delete, delete, insert, no, 3, nope, 330, that's better. I'm just going to list my code and check that that's now what it says. Yep, I think we're okay. Good, good. Now we can go to 340. Still part of the music, so this is going to explain another part of the D, the duration equals D minus 50 to D minus 20. So what this does is it controls how long the note sustains. It starts immediately, it sustains, and then it stops before the full duration end. So what this does is it gives it just a tiny break between each note so all the notes don't run into each other. So it's taking D, which is the duration, but then this little X here, minus 50 to minus 20, so it's going to go D, but not all of D, obviously, much shorter. This is just a pause, so it just creates a tiny sound break to just make each note go one after the other better, rather than just all joining up right next to each other. 350, poke, S, 136. This keeps the sound playing. Oh, I didn't call, it's not 250. My fingers are not used to this keyboard. Okay, let's make sure 250 still exists, and let's make this 350. It's only video number 1, folks. It can only get better from here. 350. There we go. All right, 360. Next, X. So that ends the sustain loop. 370, 370. For T equals 1 to D minus 5. So this is a delay loop. Actually, all that stuff I said about creating a short delay so the notes don't run into each other, it actually happens here. Doesn't happen down further. So actually what is happening up here, it's instead of using the full note length, it is just shortening the note length that we put in a bit because it does help how the sound is produced. But down here, this is what's actually creating the delay. So T is 1 to D divided by 5. So it's 1/5 of the original time. That gives us the slight delay so that the notes don't blur into each other. That's actually where it's happening. Next, T. So that's going to go through our cycles of T to finish the delay loop. 390, poke, high frequency 0. So this is going to stop the note. And then I will come back and fix the spelling of poke because that's not correct. Low frequency 0. So it's not just a matter of saying, hey Commodore, just play me this note. We have to do high frequency, low frequencies, durations, all sorts of things that need to be done. But this is what we did back then. 400, 410. Poke W, which was our waveform value. We're going to set that to 0 so it fully turns off the waveform. So that's the music covered. The next part of the code is going to deal with our flashing lights. So this is where P equals P plus 1000. So we're reading P from the data table. Here I am finally going to give you the picture that I promised that explains the data. P equals P plus 1000. So up here was actually our first value for P. and that was 203. So 203 plus 1000 is 1203. So it just saves us typing a few numbers, I suppose. But when you look at the chart, here is a chart with all the Commodore 64 points on the screen mapped. 1203 is that point there, and it's going to be lovely yellow. 565 is going to be one of our next lights. So that's going to be plus 1000, so 1565. And as you can see, there's point 1565, and it's going to be red. So that's how the P plus 1000 is working in this point of the code. 430, poke P, comma, 81. So at that point, it's poking in the Petsky character, which is the circular light. So that's what's making the light. 440, it does a bit of fancy stuff here to select a random number to make the color. So CO color equals integer random 1 times by 9 close brackets plus 2. So integer means it gets rid of any decimal points, it just keeps the whole number. And random 1, and I've forgotten one of the brackets, so that's not going to work. Random 1 will give us a random number between 0 and 1, possibly to 3 decimal places, but I would have to double check. Oh, that's actually the wrong one. So that one goes first here. Then this one goes after it. Nope, just deleted it. That's no good. Shift insert 1. Shift insert close brackets. Shift insert times 9 plus 2. And then it will times that by 9 and add 2. So it gives us the color range that we want. So it avoids 0 because we don't want any of the lights to be 0 because that would be black. 450, what it's going to do, it's going to do a little check. So if the color equals peak, so it's having a look at what's already in RAM at the moment. P plus 54272, 54272. So that just means if it is what's already in RAM now, so if CO comes up being the same number that's already there, it doesn't want to use it because otherwise the light won't change color. So here is a clever way that it does a quick check to see if it is a color that we want or if it's the same color. Because if it's the same color, it's going to say, nope, we'll do it again. Color equals 3 or color equals 5, then 440. Because we don't want color 3, we don't want color 5. I'm pretty sure 3 is green. It'd be the same color as the tree. That wouldn't work. So that's just a clever way that it checks that it's not trying to change it to the same color or one of the colors that we don't want. 460, poke P plus 54272, 54272, comma, color. So that finally applies the color to the new light, or sorry, the new color to the light. Go to 250, so that loops back and then starts the whole process again of playing the next note and doing the next tree light change. So that's essentially the code that runs the program, and now we're up to the data statements that are going to define everything that we've been writing about. So this is not that exciting, so I might end up fast forwarding some of this, but you can join me for some of it. Data 20. Actually, we've already seen this line. I just want to check that it's there because I think this is the first one that I typed in. List 1000. Yep, so that line's already there. So remember it was going to draw 20 of the spacebar character for color number 5, which is green, and then it's followed by screen ranges. So the first one it does at 83 because it does a single one, and then the next one it does at 122 to 124. So that spreads across 3 character spaces. Then it does 161 to 165. So then it moves down the next line of the tree and then it does those spaces. So that's how it's going to be reading all of that information. 1010. So now just some more data. 205, 240, 246, 279, 287. 318, 328, 328, 328, 358, 358, 368. So this is just keep doing more and more of the tree. So I think what I'm going to do now, the next few lines, I'm just going to fast forward through because I don't really have much to say. I'm literally just doing data entry to talk about the tree, talk about the lower tree, and then drawing the presents and the tree trunk at the bottom. So wish me luck. All right, this line I will say something about. What are we? Data 974, 1007, 1014, 1,0,5, 972, 972. So here we go with our -2. So these are our markers for saying, hey, we're coming to the end of one of the code sections. You're going to be jumping to a next data section. So this is where we finally finish all of the tree drawing. So all of that is just for drawing the tree. And then now my next data, which I think I've already done this line, list 1120. Yep, this is the line we spoke about before that introduces the musical notes and the colored flashing lights. So now I'm just going to get cracking with typing in the rest of the code because it is just data entry values now for playing all of the notes, the high byte frequency, the low byte frequency, the duration, and all the different colors and positions of the flashing lights. So I'm going to do that, then we'll be ready to test the program. Okay, we're at the last line, 1390, data 97, 250, 43, 0, 0, which are going to be some pauses, I think, at the end of the song, 250, 43, and here's our finish markers, -1, -1, -1, -1. So all of our data ranges there have -1. I need to save our program now. Save. Christmas tree. (8). Because it would be a shame to lose all of that. So let's list all of this beautiful code. Here it all is. Let's start running it and debugging it. I can already see an error right in front of me there, so I better go fix that. And yes, if I've gotten any of these little data numbers backwards or just wrong, it's going to be interesting. All right, cross your fingers, everybody. Here we go. Run. Okay, so the cursor is moving, but as you can see, well, yes, I've made a mistake, so let's just go and start doing some quick checking from the beginning. So I'm just going to have a little look here at my initial code, see if I've stuffed up anything there. That looks okay. That one looked all right as well. That looks okay. That looks all right as well. I suspect that I've made an error early on in my data table because that'll explain why everything's thrown off. Because if I have a number wrong or a number missing, that shifts every single thing that's being read to be totally wrong. So let's see if I can find it quickly. 410 to 500. Okay. That looks okay. So we're down to the data statements. Will that fit on the screen? Yes. I'm going to do that one again. Now the program code did not have this. I just put it in for some reason. I wonder if these spaces are causing any issues. If you know, please feel free to jump in the comments and tell me. So I wonder if they are the culprits for the initial errors that we're seeing. Or it's just probably total wrong numbers somewhere as well. Could always be that. I think I'm supposed to press enter after I fix the lines as well, aren't I? All right, enter that one, enter that one, enter that one. Let's go fix this line here. Fix that line. Okay, let's try that. Nope. All right, so now I'm just going to have to spend a few minutes just carefully going over my data entries, so just bear with me. Ha! I think we found it. So straight away in line number 1, 83 is actually there twice in the code. 8, 3, comma. So that would make quite a big difference. That'd explain why everything was stuffing up, because that value was missing. It was then reading all of the values incorrectly, because these data tables very much rely on every single number being there. Funny that. Okay, here we go. Nope, thought I'd fixed it, so let's keep checking. Here's another one of my classic mistakes. It's not 318, it's 381. No, I've written 381, but it's 318. No, restore doesn't do anything. 3, 1, shift. So 8, 318, 328, 358, 368. Yeah, I just don't... is that enough? Is that enough to have just broken that whole entire part? No, because it's all starting black and the tree should be green, and that code is being set very early on at the start of our table. 2165, 83, 83. Yeah, something else. Yep, something else is awry. Okay. All right. Let's just keep checking. Here is another one. It's not 964, it is 694. Might as well keep checking since I'm here. I still don't think that's enough to, because the fact that I'm not getting any green at the start, and that should be happening right at the start of my data table. Yes. And we're getting random characters running, we're not getting any of the music. Okay. I'm going to save, restart, because maybe I've stuffed up something in the memory somewhere. All right, we're all fresh. Let's load it. Cool, our program still exists. Maybe I just stuffed up something in the RAM. Nope. Yeah, I really feel like, because the start of the data table is correct, so I am missing something earlier on in my code. Where do we read the colors? So we start reading the colors around, so line 100 is a color value. 54272, 54272, comma 0. Yeah, that's correct. All right, I'll check the latest stuff. List 300 to 400. Is that where my error is? HLDP, HLDP, H is 1, -1, yep. Poke high frequency H, poke low frequency L. X is D to -20, that's right. S, 136, yes. Next X, 4T equals 1 to D divided by next T. Poke high frequency, low frequency, yeah, that was okay. Oh. $400, already checked that. W is 0. P plus 1000. Poke P, 81 co equals integer brackets random bracket 1. Yeah, times 9 plus 2. Yes. Look at the peak. I think I found it. Ha! Here, we are not poking the color. Line 100, it was there. I already checked it and I didn't see it. This is the issue. Okay. Why are we getting no color? Because we're not poking the color. All right, here we go. Ah, it's still not working. Oh, dear me. Okay, is this my error here? This might be it. I forgot the OR statement. That might do it, because we're definitely having issues with the color. This code is all about the color. Okay. Are we working now? No. Okay. I'm just going to put a space in there because there was a space. Just going to quickly double check this area one more time. 54272. Okay. Nope. Okay. This might be it. I forgot 4. 4x. F. O. R. Which does make a difference, yes. For x equals d. So that was stopping that. Oh, I hate when I do that stupid extra character. Okay, let's see if I can just get rid of it nicely. Okay, was that enough to break my program? Maybe. All right, here we go. Fingers crossed. Nope. Oh dear. All right, I'm going to keep checking. All right, is this going to be the problem that's breaking everything? Okay, 1110, 1100, 83 to 958, 958, 3 to 19. I've written 12, the code says 14. Surely that one number. Okay, let's try that. No. No, I really feel like something is wrong earlier on, but I just cannot find it. Okay, this would make an error, and I'm surprised that it didn't come up, but obviously dat means something else. Oh, is that all that it's going to be? Come on, surely this has got to be it. Here we go. Nope. We'll keep going. Okay. Is this it? Come on, there's not much left that it can be. Is that going to be it? Please, please, please. I can't see anything else. Here we go. No. Oh dear. Right, I'm going to have to leave it here. I've been going so long. One of my lights has gone out. I'm going to come back this tomorrow with fresh eyes. I'm just going to save it one more time. And let's see if I can get this working. Oh my goodness. I think I'm up to 4. I will just do 5 to be safe. Okay, until tomorrow. Okay, it's the next day. My brain is a little bit fresher. What I'm going to do is just list the programs to double check what I actually called the last Christmas tree program. So this is our little basic program that lets us list what is on the drive. Oh, of course I spelled it correctly. Christmas tree 5. Let's load that. Okay. Load. Now I should be able to load it, comma 8, Christmas tree 5. Okay, so I've already had a little squeeze at the code and I think I found a few things that are hopefully going to help us out. So list 1100, is that my cat walking across? Yes, thank you boy, come on, out of the way. Out of the way. Nope, he wants to be a YouTube star. To 1200. So looking down this line, this was probably staring me in the face yesterday, but I didn't see it. We have line 1110, 1120, 1140. So 1130 is not there. So I'm just going to quickly check above 1120 as well, because this is complete fiction. There's no 4-digit numbers in the original code. 1120. Yeah, this should be something completely different. This should be -2. So I don't know where the 97 came from. -2, then 38. No, is this actually line 130 that I've got there? No, I actually don't know what it is. So we're just going to type this line in again, 1120, just so I can get it nice and fresh and hopefully correct. So -2, 38, 126, 125, 203, 51, 97, 187, 565, 51. So that's line 120, 140 underneath, is that correct? That looks all right, but I don't have line 1130. So let's quickly type in that. Data 97, 62, 857, 51, 97, 375, 805, 57, 172, 250. Now there is something else that I noticed. So I'm just going to list the whole program now. And I think because I was listing it in sections yesterday, I didn't spot this, or it might have been right in front of me the whole time and I just didn't see it. 2120, that is not correct. We don't have a 2120. I think that should be 1220. So I'm just going to delete these lines because I suspect that I might have already entered them, and I'm just going to check. Yes, that camera shake was from my cat, thank you. And you know full well you need to do more than that to delete lines. All right. 2140. Gone. 2130. 2130. Gone. 2120. Gone. Okay, let's have a look at that. Okay, we're looking a bit better. So 1120, 1130, 1140, 1150, 1160, 1170, 1180, 1190, 1200. We actually have to list and insert L I S T note. 12, 10, 20, 30, 40, 50. Okay. Is that near the end? No, there's heaps more data. Okay. It's going to go bit by bit here. 60, 70, 80, 90, 1300. 1300 to 1390, well that'll fit on the screen. 13, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. That's looking a bit better. Here we go. Is this the first time we're actually going to see something that looks like a Christmas tree? Oh dear. Oh my gosh. Okay. It's all right. Again, it really seems to be something going wrong with the color and the symbols. I promise you, I'm getting this working right now. I changed my approach. I've gone through all the code very carefully off camera, and I think I've found all of our issues. The biggest issue was actually staring me in the face. I said that our big problem was there's something to do with the color and the color codes are not working. This line here, of course, this CO here is what is dictating the color, and it's not C0, it's supposed to be CO. So that was the first thing that was stopping all of the color ranges working. So once I found that, I did find that there were a few more number errors in all of my data tables. So let me see if I can try those. So the next time I run the code, everything is going to work. 1070. My data did get out of range occasionally because I had incorrect numbers. So this one here, 1028, 953, 953, 993. There's actually supposed to be two 993s here. So that 993. Okay, that didn't help at all. 993, 993. Helps if I learn to use the shift and insert 1, 38, 10. Now let me carefully check that line again. 1028, 953, 953, 993, 993, 1, 38, 10. Okay, that line is fixed. Now, list 1080 to 1100. Okay, so line 190 is there. Yes, yes, yes. Good, yeah, because a missing line doesn't help. This line here had one number, which will cause a lot of issues because it stuffs up the reading of the data table. So we should have a 97 in here. 97, 62, 830. Okay, so that line is fixed. Another couple, list So line 1280. Don't know how I did this one, but this should not be 124, it should be 149. 49. 1290. This line, one little number at the end, not 409, 405. Now I think, I'm just having a quick look at my corrections. That is it. Finally, here we have Christmas tree for your enjoyment. Oh dear. Look, that's the closest we've been. I have definitely missed something. Let me go see if I can find what it is. I thought it would work. Okay. That one's not it. Aha, hopefully this is it. And yeah, that probably would have done what we did, the 18 versus 81. So this should be 18, 918, not 981. Okay, now is that line correct? No, this line has multiple issues, so that's probably where all of our errors are. Okay, 596, no, it should be 956. 9, 5, 9, 5, 6, 960, 998, 1. Okay, is that it? Is this finally the Christmas tree? No. Oh, goodness me. Oh, I thought I had found all the errors. Okay, let's keep checking. So yes, 320 is linking us to the data table where I must have more errors. Is this going to be the final fix? About 20,000 times I've said this is the final fix. So it's not 521. It should be 321. 321, 64, 188, 125, 727, yes. 68, 149, 375. Okay. Is this it? I'm going to try and cross everything. I can't cross anything more. No, wrong notes and still a quantity error. So that means I've got a number wrong. Well, two numbers wrong actually. The one number must mean the note, the pitch is wrong. And then the illegal quantity error is just a completely wrong number. So let's keep going from where I was. Okay, there's something very wrong with this line. $57, 172, 125, 837. But then after that, I think I've started copying the line underneath. So everything after 125, no, 837 is incorrect. So that's hopefully, I'm not going to say it's the last issue because every time I've said it, I've been wrong. 76, 252, 375, 727, 68. All right, let's check that line again. 57, 172, 125, 837, 76, 252, 375, 727, 68. And I just want to check the line under it as well. 149, 125, 837, 68, 149, 125, 203, 64, 188. Okay, is it time for us to finally enjoy the Christmas tree? There we go, we have done it, finally. If you've enjoyed the video, please give me a thumbs up, please subscribe, please leave me a nice little comment. Let me know if you've enjoyed my explanations of the BASIC, if you'd like to see more videos like this. Tell me what your favourite BASIC programs were or your favourite sources of BASIC games and programs. And until then, have a happy Christmas, a great holiday, and I'll see you soon for some more 8-Bit BASIC.